We ended chapter number 12, in which we learned that how we can calculate the kinematic parameter or the geometric aspect of the motion without going into the detail of the causes of the motion. So after knowing that how we can calculate the velocity, position and acceleration of our particle, we have started the chapter number 13, which is kinetics of particle by using Newton's second law of motion. So in this chapter and the chapters onward, we will learn the kinematic parameter as well as the reason that why our particle or the rigid body is moving with certain acceleration. So we covered the Newton's second law of motion for rectangular coordinate system. We also studied the Newton's second law of motion in normal and tangential coordinate system. Now we are starting our topic that how Newton's second law of motion can be used in the cylindrical coordinate system. So these three coordinate system can be used depend on data and the required output. So let's move ahead and see the details of this topic. So for suppose we have our particle which is moving along this path, and probably the data and uh, the complex shape of this path is allowing us to use this cylindrical coordinate system. So if we are using this cylindrical coordinate system, we can represent this position of this particle by using the r, theta and z coordinates, right? So if the force which is causing its motion is F, then we will have the three component of this force. Number one is along the radial direction, the other one is along the transverse direction, and the third coordinate or the component of the force is along the z. So according to Newton's second law of motion, we can use that summation of all the forces is equals to ma. So if we want to write this equation in the component form, then we can say that all the forces in radial direction will cause acceleration in the radial direction. And in the kinematic section, we see that this ar is equals to r double dot minus r theta dot square, right? And similarly, all the forces in transverse direction and z direction will create the motion along the theta and the z direction, and these formulas we have studied in the previous section. So these are the equation for the Newton's second law of motion in cylindrical coordinate system. So if our particle or the curve is in 2D, then and we only have two uh, dimension, which is only radial and the transverse direction, and if the z coordinate is constant, then we can define the motion of our particle in a 2D plane or in r theta plane. So in this case, uh, we can uh, we can say that this we are working in a polar coordinate system. So we will only use these two equations, and we will eliminate the summation of the forces along the z direction. It will be uh, 0, because we are only working with these two dimensions. Once again, I am reminding you that the NT approach or normal tangential coordinate system, the uh, axis move with our particle, but whereas the cylindrical coordinate system or the fixed coordinate system, uh, uh, that is why our particle will move with respect to the fixed origin. So the problem involving the cylindrical coordinate system can be solved by calculating the three components of the forces along the radial, transverse and z direction, but there are some cases where the accelerated motion cannot be specified only by specifying the component of the forces. In that case, we have to define the direction and the uh, magnitude of the forces. So here we have to use this angle phi, which is the angle between the tangent line to that radial coordinate. So so this psi can be defined as the angle between the extended radial line and the tangent line, right? So for suppose our particle is moving in this direction and covering some uh, differential distance ds, and the transverse direction d theta and this radial direction dr, then this psi can be defined as dr d theta by dr. So if this is if you calculate it by in a counterclockwise direction, then it will be positive, otherwise it will be negative. So let's start solving a problem, which is problem 13-105 of your RC Himler. And in this problem you can see that we have a particle which has some mass and it is under the influence of the forces, and we are using this cylindrical coordinate system to analyze the kinematic parameter of the motion. So in this problem we can see that we have this rod, and we have this horizontal slot in which this particle can move, and this is the rod which is pushing the particle in the horizontal direction. We have an angular velocity of the rod which is 2 radians per second, and we are solve this going to solve the problem for finding out the force of the rod on the particle, and we have to calculate the normal force of the slot on the particle. So now in the previous uh, session I told you that in order to solve such problem we have to first calculate the r dot and r double dot, right? These are the position, velocity and acceleration in the radial direction, whereas theta dot and theta double dot, which is the angular acceleration, uh, we first find out these variables because we have to put this variable to find the component of the acceleration along the radial and the transverse direction. So we know the governing equation and we apply the Newton's second law of motion, which is summation of all forces is equals to uh, mass times the acceleration. So over here, if the forces are in radial direction, then it will create the acceleration in the radial direction. Similarly, if we have forces in transverse direction, then we will have the acceleration in the transverse direction. So in this component of the acceleration, we will put the values of these variable and can find the forces in that particular direction. So this is the procedure which we will follow. So in order to begin our solution, we will first see and draw the free body diagram, that what are the forces which are acting on our particle. So we will draw the free body diagram and then calculate the normal force and the force of the rod on this particle A. So in order to solve this problem, we are going to draw the free body diagram, and in free body diagram we will first extend our axis. So this is the radial direction, so we will extend it, right? And as we know that radial direction and transverse direction are mutually perpendicular, then we will draw the transverse direction. This is our transverse direction, right? Now we will see that what are the forces which are acting on our particle in the transverse and radial direction. So First, this rod will uh, applying some force on our particle. So this is the direction of the force applied by the rod. Secondly, we have a normal force which is directly upward. And finally, we have the weight of our particle which is acting downward. So these three forces uh, are acting on our particle in the specified direction. Now we will first uh, find out the r theta, r theta double dot. So we can say that this is the triangle formed by this radial component. So we can say that our cos theta is 0.5 divided by hypotenuse, which is r. So this r can be 0.5 divided by cos theta, and we can also write it as 0.5 sec theta. So in order to find this r dot, we have to differentiate it. So this d by dt 0.5 sec theta, right? So this is 0.5 d by d theta. We will apply chain rule, d theta by dt. So when you will solve it, you will get 0.5 sec theta tangent theta into theta dot, and this is the term which is theta dot, right? So now we will calculate this r double dot, and you will get the answer. So in this way we have calculated r dot and r double dot. Now we will calculate theta dot and theta double dot to calculate the radial and transverse component of the acceleration. We have provided with the theta, and theta is we have theta is 30 degree. We have theta dot, which is 2 radians per second, and we have theta double dot is equals to 0 radians per second square. So these are the values of the theta. We can convert this 30 degree into radian as pi by 6 radian. Now we know that uh, we have AR, which is equal to R double dot minus R dot theta dot square. Similarly, we have theta dot, which is R theta double dot plus 2R dot theta dot. So you can put the values in it, and you will get 1.5 meters per second square. Similarly, we have 2.6 meters per second square. So we have the value of AR and A theta. Now we are going to apply the equation of Newton's second law of motion. So we can say that we have first equation, which is sum of all the forces in radial direction is equals to MAR. So by seeing we were having the forces in this direction, which is F, the n component, and we have the weight, right? So this is the angle which is 30 degree. So we also have the uh, we also have this angle, this is 30, and this is also 30 degree angle, right? Because we have a line over here, this is the line. So if we draw our axis over there, so this angle and this angle will be same. That is why we have the forces which are n cos 30 degree minus weight times of sine 30 is equals to zero point 0.5, which is the mass times 1.5, right? So you can see that this is the n, and if you draw it, it is in it is in the upward direction. Similarly, if you draw it, you will have the component of the weight in the downward direction. That is why it is negative. So this is the equation for the Fr. Similarly, when you solve it, you will get uh, the value of n, because W is given to you. And similarly, you apply sum of all the forces in transverse direction is equals to ma theta. So in this way you can calculate it, which is F, and it is in the positive direction, that is why it is positive, plus plus W sine theta. Sorry, this is cos, this is W sine 30, and minus n sine 30 is equals to 0.5 into 2.6. So these are the equation of the motion for this particle, and when you will solve it, you will get the force, which is F is equals to 1.7 Newton, and you have a normal force by this horizontal slot acting on this particle will be 5.7 Newton. So that is how you have calculated the forces on our particle. Uh, so this is the procedure. You can analyze different forces in the cylindrical coordinate system. Now let us solve another problem, so that you have a clear idea that how to use Newton's second law of motion in a cylindrical coordinate system. So this is 1391, and in this problem uh, we have a path which is defined by a function, and this is the peg which is moving along that path due to the motion of this rod. So we have to determine the force of the rod on the peg and the normal force, and after the 2 seconds, and the peg is in contact with only one edge of the rod and the slot, and at any instant. So this means that when this cylinder move in this path, then either it is in contact with the upper surface or the lower surface. So at a time it is only facing one normal force offered by either the downward surface or the upper surface, right? So in order to solve this problem, same procedure will be adopted, that we will find the r dot, r double dot, theta, theta dot, and theta double dot, and we will draw the free body diagram, and we'll see that what are the forces acting on this peg with different directions. So let's move ahead and draw the free body diagram, and after that we will find out the kinematic parameter and will apply the Newton's second law of motion. Also, I want to mention over here that you can see over here that when this peg move in this direction, so it will this r will change with the passage of the time, and this theta will also change with respect to the time. So we will have the acceleration, we will have the angular velocity and angular acceleration in this transverse direction. Similarly, it will go away in the upward direction, moving along this path. So that is why this r will also change with the passage of time, and we will have the uh, change in position in the radial direction. Therefore we will have the velocity and acceleration represented by the r dot and r double dot, right? So we are basically calculating these change in the variable. Now again, uh, uh, it is given that we have theta, which is pi by 8 t square, and we want to see that what is the position of this peg in transverse direction when t is 2 seconds. So that is why we will put the value of time, and we will get pi by 2, and this is the pi by 2 radians or 90 degrees. So over here we can see that this is the position at which we want to calculate the force offered by this rod, and this the normal uh, and this and the normal force, right? So at this instant we will extend our radial direction. This is our radial direction directly perpendicular, and this is the transverse direction, right? Now we will see that what are the forces. So over here you can see that we have a weight acting downward, we have a force along this transverse direction offered by this rod directly in the uh, horizontal direction, and finally we have a normal force offered by this surface, which is we have a normal force which is perpendicular to the tangential line. So if we draw tangent over here, then we will have tangent like tangent like line over here. This is our tangent line, right? And we have studied that our normal force is perpendicular to that line. So this is our end. So this is our free body diagram, in which we have mentioned the forces in the normal and transverse direction, or the radial and transverse direction, and we come across three forces. Number one is weight, other one is the force offered by this rod, and the normal force, right? So now let's find out the uh, velocity and acceleration in the radial direction, and the angular velocity and acceleration of this peg. So we have r, which is r is zero point 0.5 theta. So we differentiate it. So d by dt, r is d by dt 0.5 theta, and we have theta as pi by 8 t square, right? So when you differentiate it, you will get you will get pi by 8 t. So this is our r dot, right? We again differentiate it, so we will get r double dot, which is pi by 8. So that is how we have calculated r dot and r double dot. Now we will move to calculate the theta, theta dot, theta double dot. So we can draw a free body diagram over here. So this is our peg, this is our tangent line, this is our uh, radial direction, and this is our transverse direction. We have a force over here, which is weight. We have a force of the rod, and we have the normal force, which is tangent or perpendicular to that tangent line, right? So we were calculating the uh, theta and theta double dot. We have theta, which is pi by 8 t square, right? We have theta dot, which is pi by 4 t, and we have theta double dot, which is pi by 4, right? So we have calculated the acceleration and velocity in radial and transverse direction. Now we will move to calculate the acceleration in the radial and transverse direction. So we have a formula that AR is R double dot minus R theta dot square. So when you will put value, you will get 1.5 minus meter per second square. Similarly, when you calculate the component of the acceleration in transverse direction, you will get now we will apply the equation to find out the force in the transverse and the transverse in the radial direction. Now we will apply the uh, Newton's second law of motion, which says that summation of all the forces in radial direction will create acceleration in the radial direction. So we'll first take this r, and over here you can apply the equation that we have a weight. So this is minus w, and we have a component of the normal force. So if this is the angle theta, so I can draw it as this, and this is the upward direction, this is the component upward direction, that is why it is plus n sine theta is equals to mass, which is we have a mass 0.5, and we have calculated the AR, which is minus 1.5. Now the other equation is summation of all the forces in transverse direction in a theta. So this is the radial force, we are taking it in upward direction as positive and in this direction as positive, right? So now when we apply the equation, we will get this force, which is uh, in the negative direction, that is why it is minus F, and we have a component of the force which is along the positive direction, so plus n cos theta is equals to zero point 0.5, and we have a force, we have an acceleration, and you can uh, so you have to take care that in the direction of the direction in which you are taking forces as positive, your acceleration should be in that same direction. So if the acceleration component of the acceleration is along the positive direction, that is why positive direction, then you will take the acceleration positive, otherwise you will take it as negative. So the acceleration was come out to be positive. That is why it was indicating that the acceleration is in this direction. So that is why we will take it negative, and it will be minus 3.0, right? So these are two equations for finding out the forces along the radial and transverse direction, and we have to calculate normal force and force F, and we also have to calculate this theta. So in order to calculate the theta, we would consider the psi, which is the uh, angle between the radial direction to the tangent line. So this is the theta psi which we need to calculate, so that this angle and this angle psi and this angle become equal. So we know that we have a relation to calculate this psi, and we know that this tangent psi is equals to r divided by r dr divided by d theta, right? So we have the relation which is r 0.5 theta. So when you differentiate this d by d theta, you will get 0.5, right? So so we will put the value which is 0.5 theta, and this is 0.5, right? So we will only left with the theta, and theta is it is given that this theta is actually pi by 8 t square. When you put the value of t, you will get theta, or you will get psi as 57.5 degrees, right? So this is the psi, and this is the psi. So you can put these two value angles will be same, so you can put the value of psi or theta as 57.5 and solve these equations. So when you solve this equation, you will get the uh, force offered by this rod is 4.17 Newton, and the normal force will come out to be 4.8 Newton. So that is how we can solve this problem which involves the cylindrical coordinate system. Please read this topic in your book, and after reading that topic, please attempt this reading quiz. After going through this topic again, please solve this attention quiz to check whether you have understood the concept or not.